Right now, 26,000 light-years away, at the very heart of our galaxy, something enormous is exhaling. The supermassive black hole at the center of the Milky Way, a monster 4 million times the mass of our Sun, has been quietly blowing a giant wind of scorching hot gas into space. And for over 50 years, we had absolutely no idea. Until now. This is one of the most significant astronomy discoveries in recent memory. A breakthrough that confirms something theorists have predicted since the 1970s, when scientists first began to suspect there was a black hole lurking at the core of our galaxy. Astronomers have finally found direct evidence that Sagittarius A star is actively launching a massive hot wind into its surroundings. This isn't just another space headline. It fundamentally changes how we understand our own galaxy and how black holes quietly sculpt the cosmos around them. To appreciate why this matters, you need to know a little about Sagittarius A star itself. It sits at the very center of the Milky Way, about 26,000 light-years from Earth. It contains the mass of 4 million suns, compressed into a region of space smaller than our solar system. And in 2022, the Event Horizon Telescope captured its first-ever image, a hazy, glowing ring of superheated gas surrounding a point of infinite gravity. But here's what surprised many people about that image. Sagittarius A star looked quiet. Unlike the supermassive black holes in distant galaxies, which blaze with energy, fire off enormous jets, and are surrounded by violently churning accretion disks, our galaxy's central black hole is relatively calm. Astronomers say it's in a low-power state. It isn't gorging itself on material the way other black holes do. But quiet doesn't mean inactive. And this new discovery is the proof. Here's where the 50-year mystery comes in. Black hole physics makes a very specific prediction. Whenever a black hole feeds, even just a little, the energy released should push some of that infalling material back outward as winds or jets. It doesn't matter whether the black hole is violent or gentle. If it's eating anything at all, it must be blowing something back out. One of the researchers who led this study, Mark Gorski of Northwestern University, said it simply, "Unless a black hole exists in a perfect vacuum, it must blow a wind somehow, and there is no perfect vacuum in the universe." The math was clear. Sagittarius A star had to have a wind. Scientists had been looking for it since the 1970s, but they couldn't find it. The problem is, the galactic center is one of the most difficult places in the sky to observe. It's buried behind layer upon layer of gas, dust, and hundreds of billions of stars. Peering into it is like trying to read a single word through a fog bank behind thick curtains on the darkest night of the year. There were some tantalizing clues over the years. X-ray and gamma-ray structures extending far outside the galaxy, suggesting Sagittarius A star had blown tremendous winds in the distant past. But catching it happening in real time, right now, at the source, that had eluded science entirely. Until two astronomers decided to try a different approach. Lena Murchikova and Mark Gorski, both at Northwestern University, turned to one of the most powerful radio observatories on Earth, ALMA, the Atacama Large Millimeter/Submillimeter Array in Chile. It's a network of 66 high-precision antennas spread across one of the highest, driest deserts in the world, and it can see straight through the dust clouds that block ordinary telescopes. Their key idea was to map a gas that no one had seriously searched for near the galactic center in decades, carbon monoxide. Simple, ordinary CO, the same molecule your car engine produces. At near absolute zero temperatures, clouds of carbon monoxide glow faintly at very specific radio frequencies. Map where that gas is, and more importantly, where it isn't, and you might reveal something invisible. They spent roughly 100 hours collecting ALMA data. Then, painstakingly, they subtracted the bright, constantly flickering radio glow of the black hole itself to reveal the faint structures hiding in the gas around it. What they found stopped them cold. There was a giant cone-shaped hole in the cold gas, a vast cavity where the carbon monoxide had simply been swept away or blasted into oblivion. This cone stretches at least 3 light-years from end to end, opens at a 45-degree angle, and points directly towards Sagittarius A star, tilted out of the plane of the galactic disk. Something had carved it out. Then they brought in data from NASA's Chandra X-ray Observatory, and the hot X-ray emitting gas filled that exact cone shape. Perfectly. The picture came together immediately. A hot plasma wind, blowing outward from Sagittarius A star, had plowed through the surrounding cold gas, sweeping it aside and heating what remained, like a jet of steam clearing fog. After 50 years of searching, the wind had been found. So what does this actually mean for us? For our galaxy? For the big picture? Black holes have a reputation as cosmic destroyers, but the truth is more nuanced. They're also some of the most powerful architects of galactic structure in the universe. When a black hole blows a wind, that wind interacts with the gas and dust throughout the galaxy in 2 big ways. It can suppress star formation by clearing out the raw material, the clouds of cold gas that stars are born from. Or, paradoxically, it can trigger star formation by compressing those same clouds, causing them to collapse under their own weight and ignite into new suns. In massive, active galaxies with powerful black holes, we've watched these winds reshape entire galactic ecosystems. The black hole feeds, the wind blows, and the galaxy responds. Star formation speeds up, or slows down, or shifts to a different region entirely. It's a feedback loop on a cosmic scale, but all of those dramatic examples involved powerful, highly active black holes. What about quiet ones? Like ours? That's exactly what makes this discovery so important. Sagittarius A* is in a low, calm state. It's barely eating compared to the black holes in other galaxies, and it still produces a wind. It's still actively shaping its surroundings. It's still breathing. This tells us that galactic sculpting by black holes isn't reserved for the most extreme systems. Even a quiet, almost sleepy black hole participates in shaping the galaxy around it. And since most of the black holes in the universe spend most of their time in quiet states, just like ours, this changes how we think about black hole influence across cosmic history. As Dr. Merchikova put it, this discovery shows that our black hole is not an isolated phenomenon, not some cosmic oddball. It produces a wind just like those in other galaxies. We are not special. Our black hole plays by the same rules as every other. This discovery is still fresh, and the work is far from over. The next major goal is to measure the actual speed of the gas being swept out of that cavity, which would confirm beyond any doubt that it's truly a wind and not some other effect. Future observations could even reveal the edges of that cone-shaped void shifting and wobbling over time as the wind continues its slow, relentless exhale into the galactic center. Deeper studies will also try to pin down how the wind changes as the black hole's feeding rate fluctuates, and whether the wind's direction drifts over time following the black hole's rotation. One discovery, dozens of new questions. That's how the best science always works. We live in a galaxy with a 4 million solar mass black hole at its center, one that has been quietly, continuously breathing hot gas into space for millions of years, sculpting our cosmic neighborhood in ways we're only beginning to map. It took 66 radio antennas in the Chilean desert, an X-ray telescope in Earth orbit, 50 years of theoretical groundwork, and 2 determined scientists willing to look for a gas everyone else had given up on, to finally catch it happening. The universe keeps its secrets patiently. It waits until we build something precise enough, pointed in exactly the right direction, at exactly the right time, and then it shows us something that changes everything.